Let's solve question number 11. It says a disk of mass m is held stationary by a force F exerted by a magnetic base as shown. The free body force diagram for the disk is shown below. The two forces are shown are equal in magnitude but opposite in direction. Now give two reasons why these two forces are not in Newton's third law pair. For two forces to be Newton's third law pair, there are three conditions that it should satisfy. The first condition is that both the forces should be equal in magnitude and opposite in direction. So this force which is shown here, that is mg, the weight of the disk, and the force exerted by the magnetic base are both equal in magnitude and opposite in direction. So the first condition is satisfied. The next condition is that both these forces should be acting on different objects. But when we see here, the two forces mg and f are acting on the same object. So what is the object which is acting on which this is acting on? Are acting on the disk. So which means the second condition where it should be acting on two different objects is not satisfied. So that is one reason it cannot be Newton's third law pair. The third condition should be that these two forces should be the same type of forces. Now the two forces acting which we are considering here are the weight which is of the disk and the force from the base. Now both these forces are different types of forces. Okay, so these cannot be, there are different types of forces, so these cannot be a Newton's third law pair. So that's why these two forces are not Newton's third law pair. Now one of the examples for Newton's third law pair of forces is if you are swimming, you push the wall swimming of the swimming pool and the wall pushes you back. So in this situation, both the forces that we are considering here are push forces, but whereas here these two forces are different types of forces, they are not the same type of force. So that's why this cannot be a Newton's third law pair. Now magnitude base has a weight F and rests on a horizontal table. Complete the free body force diagram for the magnetic base. Now the object that we are going to consider here is this magnetic base. Now this magnetic base also has a weight W. It's already given here. Now we already know that the magnetic base is applying a force on the disk. So the disk will also apply an equal and opposite force on the magnetic base. So along with W, you will have another force which is acting in the downward direction. So this will be force from the disk on the base. Okay, now we know that this base is stationary. So there are two downward forces. There should be one upward force acting on the base. So this upward force will be the reaction force. Now what you need to consider here is this reaction force, the total length of the reaction force should be equal to the weight plus the force from the disk on the base. Why? Because you know that the disk is stationary. So if any object, if it is stationary, then the force acting on the object should be the resultant force acting on the object should be equal to 0. So the reaction force should be equal to weight plus the force from the disk on the base of the object. Okay.